All right, we left off with this one last slide. It's somewhat of a lead-in to the next lecture, but in lecture 17 we introduced this thing called Ka or pKa, and in lecture 18 we're focused on the concentration of H plus or the pH. And I want to be very clear that there's a distinction between these two. Sometimes people will say the phrase, "Oh, what is the pH of that acid?" And the answer is an acid itself, like HF or HNO3, doesn't have a pH. So remember, pKa equals the negative log of Ka, and pH equals the negative log of the concentration of H plus. So the concentration of H plus is a property of a given solution. It's not a property of a molecule. It's not an intrinsic property of a particular acid like HNO2 or H2SO4. Those don't have a pH because you have to say what concentration they have in order to determine pH. So pH, this is a property of a particular solution. Not of the individual molecules. Whereas Ka or pKa, that's a property of a given compound. So it's a property based on the molecules themselves, how willing they are to give up H plus. All right, so to continue drawing this distinction, pH tells you the concentration of H plus in a particular solution. Sometimes you have a solution that has lots of different acids in it. And so the pH is going to be a product of a result of that whole mixture. And so it is particular to a given solution. It's dependent on concentration. So that's another important point. This is dependent on the concentration, whereas pKa, the pKa of a particular acid, doesn't change based on its concentration because it's an intrinsic property of the molecule itself. Now, in a given solution, I'm going to make that line a little shorter. In a given solution, these two are related by a simple equation that we're going to use a lot in lecture 19. And it's on your formula sheet. So if you take out your formula sheet for a minute, the question is, do I have extra copies of the formula sheets? I will have to check. It looks like all the extra copies have been pilfered from the back of the room. So on your formula sheet, you'll see an equation that relates pH to pKa. And let's see, did I give it in the form they give it? No, I gave it in a different form than they give it. Oh no, I gave it in the form they give it. Perfect. So in a given solution, essentially the pH of the solution will be related to the pKa of a specific acid based on the ratio of acid form to conjugate base form. Remember, HA represents acid concentration, and then A minus here represents conjugate base concentration. So make sure in discussions moving forward, you don't refer to, oh, the pH of H2SO3. H2SO3 is a particular acid. It has a pKa, not a pH. And you don't want to say, oh, the pKa of this solution is 6.5. No, that would be the pKa of a particular acid in the solution, maybe. So these two are distinct ideas that are related mathematically, but I want to make sure we start drawing that distinction between the two. Question? So the question is, wait, this logarithmic form, can't we just say this equation in terms of concentration of H plus and in terms of Ka? And yeah, we definitely have done that already. So this equation here is not really a new equation. It's just the logarithmic form of the equation that we've already seen, which is the definition of Ka. Ka equals concentration of H plus times concentration of A minus divided by concentration of HA. Essentially, if you take that equation and you take the negative log of both sides and then rearrange it, you get this equation over here on the right. So it's not a new equation. I actually will start lecture 19 by just deriving the equation. This relationship in the logarithmic form, we call this the Henderson-Hasselbalch equation. I don't know how they got their names attached to it just by taking negative log, but they did. They were. So this is known as the Henderson-Hasselbalch equation. You don't need to memorize that name. It just they also if you have a long name, collaborate with someone with a short name so that when they name something after you, it doesn't become so cumbersome. Yeah, we usually call it the HH equation. All right, other questions? So the student question is, why is the drug acid called acid? I have no idea because LSD is not actually an acid. It has acid in the name. It's called lysergic acid diethylamide, but even that is not. It's a common name. It's not a systematic name. So I don't know. Like where that came from. I also don't understand why it's LSD because it's lysergic acid diethylamide. It should be LAD. I don't know. So the point is, sorry, I can't shed any light on that. The thing about names, though, names of chemicals are kind of like names of people in that when someone gives you a nickname that sticks, like there's no going back to your regular name. So like chemicals like acetic acid, well, that's what everyone calls it. Its official name is ethanoic acid, but no one ever says that. Why? Because, well, it's just acetic acid. You know it as acetic acid. Like, that guy's not James. I know him as Jim. Like, he's Jim. Don't try and tell me he's anything but Jim. So, same deal. The question is, do you know what happens when you take the pH of a fish tank and it turns a cool color? And the answer is yes, I do, and that's going to be something we talk about in depth in lecture 19. So in lecture 19, you'll see there's lots of slides with pictures of colors on them. That's where we're discussing indicators and why they change color when you change the pH. Yeah. All right, any other questions? Oh, the question is there an equation that relates pOH and pKb in the same way? And the answer is sure, definitely. You can write the same equation, the same kind of equation for pOH, and it would be pOH equals pKb plus the log of conjugate acid over concentration of base. So yeah, that equation exists. We just tend not to use pOH. pH tends to be the number that we focus on. Question is this still called the HH equation? I don't know. Probably not. Oh, I like that. Student said maybe it's the OH equation. It's good. And now everyone said, oh, which is also a pun. Yeah, and then some students said ha ha, which is also a pun. All right, I think we need to stop.